4.1, we're looking at the 8 fundamental identities. An identity is an equation where all values satisfy both sides. For example, if I said 2 times x plus 1 is equal to 2x plus 2, those are the same thing. No matter what value of x, it satisfies both sides of that equation. In this unit, you're going to be manipulating equations using known identities to make both sides look the same. It can be frustrating if you are not willing to make mistakes and to start again. So a good thing to have in front of you would be your formula sheet, and we're looking at the identities found at number 8, 9, and 10. And I'm going to show you where these identities came from, and then we're going to go through how we use them. Okay, so the reciprocal identities. We know that cosecant equals 1 over sine squared. So if we multiply both sides by sine, we get cosecant times sine is equal to 1. And similarly, we could massage that and say that sine is equal to 1 over cosecant. Okay, cotangent is equal to 1 over tan, multiplying both sides by tan, and then also solving for tan. Secant is 1 over cos, so secant times cos is equal to 1. Similarly there. So those are the reciprocal identities. Then we have our quotient identities. Well, tan is equal to sine over cos, so tan times cos is equal to sine, and cos is equal to sine over tan. And we can do similar with cotangent. Pythagorean identities. These might be new. Cos squared plus sine squared is equal to 1. That's going back to the unit circle for some of you. Okay, cos squared is equal to 1 minus sine squared. And this can further be massaged. We have a difference of squares to be 1 minus sine, 1 plus sine. 1 plus tan squared is equal to secant squared. Same thing, we can solve for tan squared. We have a difference of squares. And similarly, 1 plus cotangent is equal to cosecant squared can be represented in a number of ways there too. How we use these. If we know sine and cos, we can if we know sine and cos, we can get tan because we know that tan is equal to sine over cos. So we just go 0.848 divided by 0.59. We can solve for tan. And I went through and did similar things here using identities and things that we know. If we're given one value, we can find the others. Okay? Here's another example. If sine is equal to 15 over 7 in quadrant 2, find the exact value of cos. So I'm going to use the identity sine squared plus cos squared is equal to 1. Putting in sine as 15 over 17, squaring it. And now I'm going to solve for cos. So I get 1 minus 225 over 229. What I did here is I said, well, 1 is just 289 over 289. Solving that, I get 64 over 289. I square root both sides, and I took the negative answer. The reason I took the negative answer was because in quadrant 2, cos is negative. Okay, another problem here. If I told you what cos was, and it's a fourth quadrant, I could determine the value of tan. First thing I did is I said, well, cos, its reciprocal is secant, so I could say secant is equal to 5. And I'm looking for an identity that has tan and secant in it. Oops, wrong window. Tan and secant in it, and I see tan and secant, I have 1 plus tan squared is equal to secant squared. So I'm going to use that identity. So 1 plus tan squared equals secant squared. Subbing in 5, I get tan squared is equal to 25 over 1. So tan squared is equal to 24. Then I'm going to square root both sides, and I took the negative answer. And the reason I took that negative answer is because we're talking about a fourth quadrant angle. Okay, there's one more video for you to watch. You want to always, when you're doing these questions, have that formula sheet in front of you so you get familiar where these identities are located and how you can manipulate and use them.